Hi, and welcome to week 5 of the TheMathsTutor.ie 30-week countdown for leaving Cert Ordinary 11 Maths. This week in week 5, we're going to be looking at forming equations, indices, and rearranging equations. So as always, this is part of the 30-week countdown. So that's available to all of our full members on the website. And as always, we're going to take a few of those videos and make them available to everyone who's watching these lessons. So the first one there is on forming expressions. So this video just goes through how we can take words and turn them into maths. And the second one, which we won't get a chance to look at today, is on surds. So this is where we're dealing with things like square roots and things like that. So there's 2 videos for you there in the comments that you should be able to go and look at after this class on these topics. So today then what we're going to be looking at is how we form equations, and then we're going to look at a little bit of indices and a little bit of rearranging equations. So when we talk about forming equations, this is where we're going to be given information in words, and we're going to have to turn it into a mathematical equation. Sometimes people find this difficult because they just don't break down the reading that comes or something like that. So with something like this, I'm going to be highlighting what kind of words do we come across. So this is from the 2012 paper 1, and it's question 7 part B. So the start of the question said, doctors sometimes need to work out how much medicine to give a child based on the correct dose for an adult. There are different ways of doing this based on the child's age, weight, height, or some other measure. So there was part A to this question, but it's the part B that we want to look at that says another rule for working out the child's dose is called Young's rule. Below are 3 different descriptions of Young's rule taken from the internet. In each case, write down a formula that exactly matches the description in words. And then it gives us a few terms and conditions. So state clearly the meaning of any letters you use in your formulae. So formulae, we just mean formulas. It's the plural that we're going to be using. And it means we're going to be doing this 3 different times. So there's 3 parts to this question. And we just have to explain what the letters mean. So it doesn't matter which letters you use, as long as you explain what those letters are. Okay, so these variables are going to be about the child's age, the dose that we're going to be giving them, and the adult dose. So the first one says, a mathematical expression used to determine a drug dosage for children. The correct dosage is calculated by dividing. So that's a key word that I'm going to spot there. We see dividing the child's age by an amount equal to the child's age plus 12 and then multiplying. So I see there's 3 different parts to this. So it's asking me to do some dividing, it's asking me to do some adding, and it's asking me to do some multiplying. I have to make sure that I'm following the order that this question is in. So what are they asking me to do with each part of these? There's a couple of times that they'll word things a little bit differently that I need to make sure that I'm understanding. So dividing, they might say quotient. Multiplying, they might say times. Plus, they might say sum. So they're just some other words that we come across that tell me to do the same sort of thing. So it might say times, it might say sum. And another one that comes up is difference. And if I see difference, I know that we're looking at subtract. We have to make sure that we're using them in the right order as well. So this question here, so we have to make sure that we're keeping a track of what all of our letters are going to mean. So the way that the marking scheme went with this, and we'll do the same, is that C was the child's dose. So that's what we're going to be working out. Y was the child's age in years. And A was the adult's dose. Now, as we said, it doesn't matter what letters or what variables you use for these. They have just picked these ones, and you can have picked absolutely any ones that you want yourself. So what we're looking for is to determine an expression to work out the drug dosage for children. So we're looking at what is C going to be. So what is my formula for working out C? So we're going to be saying dividing the child's age. Well, we've said the child's age here was Y, so we're going to be dividing Y. So that's Y divided by an amount equal to the child's age plus 12. So I'm going to be dividing Y by Y plus 12. Okay, so let's just make that a little bit neater. So we're going to be saying Y divided by Y plus 12. So that answers this part here that says dividing the child's age. So we'll just put in a different color. Dividing the child's age by an amount equal to the child's age plus 12. And then it says, and then multiplying by the usual adult dose. So then we're going to multiply that by the adult's dose. So this is our formula, and this is going to be equal to our child's dose. So we're just breaking down what it's asking us to do in the question. So dividing the child's age, so we said that's Y, by an amount equal to the child's age plus 12, so that's Y plus 12, and then multiplying by the usual adult dose, and then multiplying by A. So that's the first formula that we get using this method. The second one it asks us to do then, it says a rule for calculating the dose of medicine correct for a child by adding 12 to the child's age. So there's adding, dividing the sum by the child's age, and then dividing. So we've got two lots of dividing here. So we're going to break it down and start again. So we're going to use exactly the same variables. So C was our child's dose. Y was our child's age in years. And A was our adult's dose. Okay, so again, we're going to start by saying adding 12 to the child's age. So that's the first thing that I'm seeing here. Adding 12 to the child's age. So the child's age is Y, so I'm going to say Y plus 12. Dividing the sum by the child's age. So that's the next part. So dividing the sum. So remember, the sum meant to add them together. So there was our adding. So we have added them, and we're going to divide that by the child's age. And then this part says, and then dividing the adult dose by the figure obtained. So by this answer, we're then going to have to divide the adult dose by this. So this was our first part. So the part that's highlighted there, adding 12 to the child's age, dividing the sum by the child's age. But now we have to make another part to this fraction. So we're going to be saying the child's dose is equal to the adult's dose divided by all of this. So Y plus 12 over Y. And we don't need to simplify that any further because that's what the question asked me to write it as. So the adult's dose divided by the child's age in years plus 12 divided by the child's age in years. And it looks very complicated, but when we break it down, we're just taking each part of that question and breaking it down with our variables and following what the sum asks us to do. And in the third method that it gives us, the dose of a drug for a child is obtained by multiplying. So there's one of our what do we want to do? The adult's dose by the child's age in years and dividing the result by the sum. So remember, the sum meant adding. So the sum of the child's age plus 12. So again, we're going to say, let's break this down. So we'll start with multiplying the adult's dose by the child's age in years. So C again is the child's dose. Just to remind you what our variables are. Y is the child's age. And A is the adult's dose. So we're saying the adult dose is going to be multiplied by the child's age in years. So the adult dose gets multiplied by the child's age in years. So A being multiplied by Y. And then it says dividing the result. So dividing that part by the sum of. So I'm going to divide this by something. And I'm dividing it by the sum of the child's age plus 12. So that's going to be Y plus 12. and that's C is equal to again. So there's 3 different ways of breaking down a question, taking what parts they've given me and working out what are they actually asking me to do with these letters. So that first video there on forming expressions goes through another couple of examples there of taking variables written in words and converting them into maths letters and numbers and things like that. So that's the first part where we work on forming expressions or equations. The second thing that we're going to look at today then is we're looking at indices. So what we need to look at our indices, sometimes they're called our powers, sometimes they're called our exponents. What's really important is when we're dealing with these that we're going to be using page 21 of our tables. So I've just put in a little snip of the part of page 21 that we're going to need to use. So we're using just the first column here, and this is all our indice rules. Okay, so we're going to keep using our indice rules here. When we write something as an indice, we're going to have a large base number and then we're going to have a power. So something like writing 2 to the power of 3. And that means 2 multiplied by 2 multiplied by 2. So 2 multiplied by itself 3 times, and I could put that into the calculator and get 8. I could also have variables or letters, so I could have something like 4 to the power of x. And when I have an unknown or a variable up in my power, we're going to have to use our indice rules to solve for it. So we have a couple of questions here that we're going to look at. The first one is 2019, question 6, part B from paper 1. And I've just highlighted what it's asking me to do. So it's asking me to solve for x. So I know when I want to solve for x, my last line should be x is equal to a number. When I look at this sum, the x is up here in the power. So that's where I'm seeing it here, up here in the power, 2 to the power of 2x minus 1. And when I see it up there, that's my clue that I'm going to need to use page 21 of my tables. Okay, so that I might need some of these formulas from this. When I have an equation and I want to solve it and the unknown or the variable is in my power, what we need to do is we need to write both sides of the equation as the same base number or the same big number. So this side looks fine because we have 2 to the power of 2x minus 1, and that is 2 to the power of something. But the other side at the moment says 64. I want to write this as the same big number or the same base number as I have on the left-hand side. So on the left-hand side, I'm going to have a 2. So I want to write 64 as 2 to the power of something. And we can do this using our calculator. So just by trial and repeat. So when we take out our calculator, we can just start with 2 to the power of, and we can try out numbers. So we saw 2 to the power of 3 was 8. We're looking for 64, so 2 to the power of 4 gives us 16. 2 to the power of 5 gives us 32. And 2 to the power of 6 gives us 64. So we're going to rewrite 64 as 2 to the power of 6. So we now have 2 to the 2x minus 1 is equal to 2 to the power of 6. And once we have written an equation with the same base number or the same big number, the powers are going to be equal. So in this case, I can now say that 2x minus 1, the power on the left-hand side, is equal to 6 because they're both 2 to the power of that. So that means that I'm going to say 2x minus 1 is equal to 6. We'll add 1 to both sides and divide both sides by 2, and we get x is equal to 7 over 2. And you can sub that back in. So if you wanted to check your answer, you can sub in. So we can say 2 to the power of 2 times 7 over 2 minus 1. And when you put that into your calculator, so 2 to the power of, calculator not responding there, sorry, 2 to the power of, and we say 2 times 7 over 2, which was our answer for x, minus 1. And we get 64. So that's just a nice way to check that we have that sum done correctly. So that gives us 64. Now, I didn't need to use any of my formulas from page 21 in that one. All I had to be able to do was write 2 to the power of on both sides. Whereas in the second one that we look at here, so this is 2013, question 3, part C, and this also says solve the equation. So I'm going to solve the equation, and when I spot that the x's or the variables or the letters are up in my powers, I know that I'm dealing with indices. I'm going to have page 21 open. On the right-hand side this time, I see I have a 3. On the left-hand side, I have a 27. So I'm going to see, can I write 27 as 3 to the power of something? And again, you would just go to your calculator and trial them out. So on my calculator, I find that 3 to the power of 3 is equal to 27. So I'm going to rewrite the 27 as 3 to the power of 3. But this time when I rewrite that, you'll see that I have a power inside a bracket and a power outside a bracket. So the 27 was already being raised to the power of 2x, and now the 3 cubed has to be raised to the power of 2x as well. So now I have a power inside a bracket and outside a bracket. And this is going to tell me to use page 21 of my tables. So on page 21 of my tables, I see this formula, which says a to the power of p in a bracket with a q as a power outside a bracket is the same as a to the power of p touching q. And when p is touching q, that's going to mean multiply. So we're going to take this formula and we're going to apply it. So a times p to the q is equal to a times p to the q. So it tells me to multiply. So we had one power inside a bracket and one power outside the bracket. And we said that's the same as that base number being raised to those powers being multiplied. So I'm going to take the power inside the bracket and outside the bracket, and I'm going to multiply them. So that's going to be 3 to the power of 3 times 2x is 6x. And on the right-hand side, we have 3 to the power of x plus 10. And there's nothing that I need to change on that right-hand side. I have that big base number of 3, and it's to the power of x plus 10. So now by using the formula from page 21 of my tables, I've now rearranged this to get the same base number on both sides. And now I'm going to say these powers are equal. So we're going to take the 6x and put it equal to x plus 10. And we're just going to solve for x. So 6x is equal to x plus 10. I'm going to subtract x from both sides. And I get 5x is equal to 10. And I'm going to divide both sides by 5 to get x is equal to 2. And again, we can check if our answer is correct by subbing in. So I could say 27 to the power of 2 times 2. And I want to see, is that the same as 3 to the power of 2 plus 10? So on my calculator, I can type 27 to the power of 2 times 2 equals, and I get 531,441. And on the other side, we had 3 to the power of x plus 10. And we get exactly the same number. So again, that's a nice way just to check that we've done our sum right when we check on our calculator that those two sides equal. So that's using our indices to solve equations. And I know that I'm going to be using that whenever I see my variable or my x or my letter in my power. So when it's in the power, I'm going to use that method. The last thing that we want to look at today is we're going to look at rearranging and using formulas. So this is 2019 question 8A. So this is only a part of it here. So we're just going to look at question 8A. So part A says the power P of an engine is measured in horsepower using the formula P is equal to R multiplied by T, all divided by 5,252. Now we just have to make sure that we're reading the question carefully and seeing what they describe each of these things as. So it says R is the engine speed in revolutions per minute, and T is the torque measured in appropriate units. So when we read the question, we're going to see do they explicitly tell us this is the engine speed and this is the torque, or do I have to pick it out looking at my units? So the first part of this question says find the power. Now the power was P. So we know from this formula that we'd said find the power P. So this question is going to be what is P equal to? So find the power of an engine that generates 480 units of torque. So that's picking out what T is going to be at 2,500 RPM. So it doesn't tell me that this is the engine speed, but when I see the units, RPM, I go back up here where it said, where R is the engine speed measured in revolutions per minute. So this is going to be R. So to work out P, I can just use this formula straightforward and sub in. So P is going to be equal to R, which is 2,500, times T, which is 480, divided by 5,252. And that's going to be a straightforward one to put into our calculator. And we get 228.48. And I stop there and I go back and check the question. So the question says, give your answer correct to the nearest whole number. So when I want the nearest whole number, we want nothing after the decimal point. So we're going to be keeping all of these figures here, but I need to look at the one just after the decimal. If that's a 0, 1, 2, 3, or 4, I leave the number in front of the decimal alone. If it's a 5, 6, 7, 8, or 9, I'm going to round up. So here we're going to say P is equal to 228, and I'm not going to round up the 8 because the number that comes after the decimal is a 4. So my answer here for the power of this engine is going to be 228. And it's measured in horsepower, so it doesn't have to have any units. So we're just going to say the power is 228. The second part of that question that we're going to look at says rearrange the formula to write R in terms of P and T. When we want to rearrange a formula, we have to make sure that we're reading a question carefully. So I've highlighted again, it's asking me here to rearrange the formula to write R in terms of P and T. When it says R in terms of P and T, it means that I want R equal to, and on the other side, we can have P and T and numbers, but no R. All right, so that's important that we can only have R on the left-hand side, and we can only have one R. So we're not allowed to have 2 R or R plus 6 R or anything else like that. It has to just be one R on its own, and it's equal to. And on the other side, so when it says to solve for R, so like in the first part of this question, it said to solve for P, I was getting P is equal to a number. But when I'm rearranging this formula, we're going to get R is equal to, and we can have letters and numbers on the other side, but we can't have the letter that we wanted, all right? So we can't have the letter R over on the right-hand side. It has to be on the left-hand side on its own. This is called changing the subject of a formula as well. So this might be written as make or the subject of the formula. So that would mean that we need to write or equals. And that's just another way that they can give it to us to explain it to us. So where we're going to do with this is, or how we're going to solve this question, is that we're going to start by writing out the formula that they gave us. So in this question, up here at the top, it said P is equal to R times T divided by 5252. Sorry, screen not moving again. Okay, so or is equal to P, sorry, the other way around. P is equal to or. P is equal to or times T divided by 5252. So remember, we want or equal. So it said rearrange the formula to write or in terms of P and T. So I want or on its own. I need to rearrange this formula to get or on its own. So the first thing that I'm going to deal with here is I have one fraction on the right-hand side. So I'm going to multiply both sides by the bottom line of that fraction. And that gives me 5,252 multiplied by P is equal to or times T. So that got rid of the fraction over on the right-hand side for us. We managed to bring that number over by multiplying. Again, I'm keeping an eye that I want or on its own. And at the moment, I have or multiplied by T. So we're always trying to undo the sum that we have in front of us to get that on its own. So how we would do that is by dividing by T. So 5252 multiplied by P divided by T is going to give me or. You don't have to have the multiply by sign there on the top line because we know when a number is touching a letter, it means multiply. So I could write that as 5252P divided by T is equal to or. But either of those lines are the correct answer. So what we can see is that we now have or on its own and or is equal to. So we have rearranged this formula to get or on its own. We see that there is a P and a T in our answer, or in our other side of our equation here. So or is equal to something that has numbers and P's and T's, but we can't have any ors on that side. We'll see another example of this rearranging equations in 2018 question 9. So this question says, when earthquakes occur under the sea, they can cause large tidal waves called tsunamis. Scientists can estimate the arrival times of tsunamis to nearby countries. The average speed at which a tsunami travels is given by the formula. So here we have another formula where S is the speed of the tsunami in meters per second, D is the depth of the ocean in meters at the location where the earthquake occurred, and G is equal to 9.8 meters per second squared. So they're going to explain to me when I have to read through this part at the beginning, what do each of these letters or variables mean in the formula? So the first question says, find S, the speed of the tsunami, when the earthquake occurs at a depth of 2,000 meters. Give your answer in meters per second. So this is straightforward. And the reason that this is straightforward is that this formula gives me the speed because it said S is the speed. So we just need to sub in. So we're going to say S is equal to the square root of G was equal to 9.8. multiplied by, it occurs at a depth of 2,000 meters, and D is the depth in meters, so I don't even need to change my units. So D is equal to 2,000. So the square root of 9.8 multiplied by 2,000, and that gives me 140 meters per second. So that part is just sub into my formula. The second part of this is using our answer from part A. It's going to say a tsunami has been identified at beginning 400 kilometers from land. The depth of the ocean at that point is 2,000 meters. So there's our depth again. Find how long it will take this tsunami to reach land. So this question is how long. So this is a distance, speed, and time question. So how long is asking me to find the time. So time is going to be equal to distance divided by speed. I know that when the depth of the ocean is 2,000 meters, the speed is going to be my answer from up here. So my speed is going to be 140 meters per second. I do have to change my units here. So I said in the last one I didn't, but this says 400 kilometers and my units up here were meters per second. So these have to match each other. So we're going to convert this by saying 400 kilometers and we multiply that by 1,000 to convert it to meters. And now we're going to put that into our formula as distance. So that's 400,000 divided by our 140 meters per second. So that's our distance on the top line, our speed on the bottom line, and I get a time of 2,857.14, and that'll be seconds. So this was meters per second, so our time is going to be in seconds. But again, we need to read our question, which says, give your answer correct to the nearest minute. So to convert seconds to minutes, we're going to be dividing, and we're going to be dividing by 60. So when I divide this by 60, I'm going to get an answer of 47.62 minutes, and we need to round that off. So again, to the nearest minute means I'm going to be keeping everything in front of the decimal. This time, the first number after the decimal is a 6, so I round up and I get 48 minutes. And then we're going to see the part about rearranging our formula. So this time it says rearrange the formula to give D in terms of G and S. So we want D is equal to what? So from our formula at the top, we can see S is equal to the square root of G times D. So S is equal to the square root of G times D. We want D equal to. So D is going to be our subject of the formula, and we're allowed to have G's and S's and numbers if we want over on the other side, but we can't have any D's over on the other side. So we want D on its own. What's different about this one to the other example we looked at is that here we have a square root. So to undo a square root or to get rid of that square root, we're going to have to square both sides. And when we square both sides, we get S squared is equal to G multiplied by D. And to get D on its own, all that's left to do is divide by G, and we get S squared divided by G is equal to D. So I can see now we have D on its own equal to G and S, something in terms of G and S. So we have D in terms of G and S, and we have rearranged that formula. So D is now the subject of that formula. The last part of that question, and I've highlighted here that it says, hence or otherwise, find the depth of the ocean. So when it says hence, we have to make sure that we would use this answer. When it says otherwise, we can go back and use the answer from the beginning. So it doesn't matter with that one. All we would be doing there is subbing into one or other of those formulas. So it's going to say the depth of the ocean where an earthquake occurred if the resulting tsunami has a speed of 55 meters per second. So we know that that's S, and give your answer correct to the nearest meter. And we know that G stays the same each time. So we're going to be saying D is equal to 55 squared over 9.8, which is what G was from the beginning of the question. And when we put that into our calculator, we get 308.67. So to the nearest meter, we're going to round off again. So 309 meters deep. So hopefully that was of some use to you there. We saw some rearranging equations, some solving indice equations, and we saw some how we make expressions or formulas when we're given information in words. And don't forget, we have 2 videos there for you. So on forming expressions and one on Certs, and all of this information is on the exam countdown on TheMathsTutor.ie, the 30-week countdown.